Okay, so it is a shaft supported by two bearings. So where you got two pulleys, one is on extreme left, another one is on extreme right. So both got a different diameter. Both pulleys got a different diameter as well as different weights. Okay? So now we just note down the layout diagram. It is supported by two bearings. Okay, so the distance between bearings is, it is a 500 mm. So now this distance is 500 mm. Pardon. And you got a two pulleys which are placed at a distance of 250 mm to the right side as well as to the left side. Okay. So one pulley which has a diameter 250 mm and two is 500 mm. So this one is 250 and this one is 500 mm. Okay. The masses of pulley 1 is a 10 kg. Now this is going to weigh 10 kg here and this is going to weigh 30 kg. Okay. The belt tensions act vertically downwards and the ratio of belt tensions on tight side to slack side. That is what? So T1 by T2 is equal to 2.5. The shaft is made up of 40C8 material. So here you got a sigma y is equal to 380 Newton per mm square. And factor of safety, it is what, about 3 here. Okay. Estimate the suitable diameter by using the strength, and if the permissible angle of twist is 0.5 degree per meter length, calculate the shaft diameter basis on the torsional rigidity. So now they have provided G also. So based on G, you need to calculate what is the diameter of the shaft here. Okay. So you got two support A, B. So you got a pulley. Let us go for, this is what a pulley 1. Okay, and this is what a pulley 2. Right. So if you note down given data, so power is given, it is 7.5 kilowatt, speed is given, it is 360 rpm. Okay. Now diameter of pulley 1 is 250 mm, diameter of pulley 2, it is 500 mm. So weight of the pulley 1, it is a 10 kg. I am going to consider this as a 100 Newton. Okay. Weight of the pulley 2, it is a 30 kg. So here I am going to take it as a 300 Newton. Right. So theta is given, it is a 0.5 degree, and sigma yt, it is 380 megapascal. Already I noted. FOS is given, it is a 3. So now as the power is given, you can calculate the torque transmitted by the shaft. Speed ಕೊಟ್ಟಿದ್ದಾರಾ, ಪವರ್ ಕೊಟ್ಟಿದ್ದಾರೆ. ಟಾರ್ಕ್ ಕ್ಯಾಲ್ಕುಲೇಷನ್ ಮಾಡಲಿಕ್ಕೆ ನೀವೇನು ಯೂಸ್ ಮಾಡ್ಬೋದು ಅಂದರೆ, ಸೊ ಡಾಟಾ ಬುಕ್ಕಲ್ಲಿ 3.2a ಯೂಸ್ ಮಾಡಿಕೊಂಡು ನೀವು ಕ್ಯಾಲ್ಕುಲೇಷನ್ಸ್ ಮಾಡ್ಬೋದು. Now let us first calculate torque transmitted by the shaft. Okay, so refer design data handbook, you notify equation. So T equal to, it is 9.55 into 10 to the power of 6 into P divided by N. So 9.55 into 10 to the power of 6 into 7.5 divided by 360. 198.95. Okay. Now this is what is transmitted by the shaft, right? Now, as it is going to transmit the power in vertically down direction, okay, vertically down direction. So now let us consider belt tensions in pulley 1. Belt tensions in pulley 1. So now if you take a diagram of this pulley 1, it has a diameter of how much? 250 mm. So let us take, it is rotating in clockwise direction. You got a T1P. Okay, so I will go for T11. ಮೇಡಮ್ ಅವರ ಕ್ಲಾಸ್ ಮುಗಿಸಿ ಬರ್ತೇನೆ ರೀ. So T1, I'll go for it as a T11. Okay, so T12. T1, it is for tension on tight side of the pulley 1. T12 tension slack side tension of pulley 1. Okay. Okay, so it is 100 Newton. Now you just observe how many forces are acting in a down direction totally. So now forces which are acting in down direction, 1 tension on tight side of the pulley 1, tension on slack side of the pulley 1, as well as weight of the pulley 1. Right? You know value of WP1. ನಿಮಗೆ ಏನು ಗೊತ್ತದೆ ಇಲ್ಲ WP1 ವ್ಯಾಲ್ಯೂ ಗೊತ್ತದ ಹೌದಾ? ಸೊ T11 ವ್ಯಾಲ್ಯೂ ಗೊತ್ತದ, T12 ವ್ಯಾಲ್ಯೂ ಗೊತ್ತದ? ನೋ. ಬಟ್ ಹ್ಯಾವ್ ಎ ಬೆಲ್ಟ್ ಟೆನ್ಷನ್ ರೇಷಿಯೋ. ಬೆಲ್ಟ್ ಟೆನ್ಷನ್ ರೇಷಿಯೋ ಏನು ಕೊಟ್ಟಿದ್ದಾರೆ? T11 by T12 equal to 2.5. Okay. Now, have you noted up to this stage? ಬರ್ಕೊಂಡ್ರಿ ಇಲ್ಲಿವರೆಗೆ? Now, so torque transmitted by the belt drive. Torque transmitted by the belt drive. So now I am going to say it as a T. So here it is dP1 divided by 2 in bracket T11 minus T12. It is a standard formula. So what it is? Torque transmitted by belt drive, radius of pulley in bracket tight side tension minus slack side tension. So RP stands for radius of pulley. Okay. Now by the belt tension ratio, T11 equal to 2.5 times of T12. Agree na? By belt tension ratio. Now let us substitute. So T equal to diameter of pulley, it is a 250 mm divided by 2 in bracket 2.5 T12 minus T12. How much you are going to get? T equal to, it is 125 into 1.5. How much you are going to get? So 250 into 2.5 divided by 2 into T12. How much you got? Sorry, 1.5, not 2.5. It is a 1.5. Yes, Aito? Now, the torque transmitted by the shaft is going to be received by the belt drive, right? It is going to be received by the belt drive. You can note down if you are getting confusion. Torque by shaft is equal to torque received by pulley. How much value you got? 19. Torque value is 198.958.33 equal to 187.5 T12. Now T12 equal to so 198.958.33 divided by 187.5. 1061.11 newtons. Okay. Now tension on tight side equal to 2.5 times of T12. 2.5 into 1061.11 to 0.77 Newton. Clear? Is it clear? Right? Okay. Belt tensions on pulley 2. Right? So what is the diameter? Its diameter is 500 mm. Right? Okay. Now let us calculate. So T equal to dP2 divided by 2 in bracket T21 minus T22. So now diameter of the pulley is 500 divided by 2. So this is how much? So 2.5 times of TT2 minus TT2. So you are going to get 250 into 1.5 into T22. So 1 is equal to T. How much? 3, 5, T22. Okay. Now again we calculate the torque tension of the belt on tight side as well as slack side. Okay, what is the torque? It is a 198,953 point. Let it be equal to 375 T22. How much you got? 530. Okay. Now note down. Let us go for force diagram, or you can say it is what a load diagram. So you got a two support. Let us go for this is what RA. You got a RB. Now distance between these two support it is a 500 mm. Now the net force which is acting at a pulley is in a down direction. Similarly, net force which is acting at a pulley pulley 2 is also in a down direction. So now this is what T21 plus T22 plus WP2. So here it is a T11 plus T12 plus WP1. So you can say total force which is acting at a pulley 1, it is a T11 plus T12 plus WP1. Let us substitute all values and find out. So similarly for pulley 2, it is I am going to take it as a F2. It is T21 plus T22 plus WP2. So you can calculate T12. T12 how much you are going to get here? It is a 2.5 to 530. This is how much? F1 is how much? Okay. So I calculate T12. It is a 2.5 into 530. 1. Somewhere you made a wrong. Check it. Okay. 1326.38. Okay. So how much here you are going to get? It is a 1852186. Okay, 21. Right. Now let us calculate reaction force at A and reaction force at B. Reaction force at A, reaction force at B. Now, if you take, I'll mark this point as a, this point as a B, this point as a C, and this point as a D. ಹೌದಾ ಇವಾಗೆ ಯಾವ ಪಾಯಿಂಟ್ ಮೂಮೆಂಟ್ ತೊಗೊಂಡ್ರೆ ನಮಗೆಲ್ಲ ಕ್ಯಾಲ್ಕುಲೇಷನ್ ಸಿಗ್ತಾವೆ, ವ್ಯಾಲ್ಯೂ ಸಿಗ್ತಾವೆ. ಸಿ ಪಾಯಿಂಟಿಂದ ತಗೋಬೇಕು, ಎ ಪಾಯಿಂಟಿಂದ ತಗೋಬೇಕು, ಅಥವಾ ಬಿ ಪಾಯಿಂಟಿಂದ ತಗೋಬೇಕು, ಅಥವಾ ಡಿ ಪಾಯಿಂಟಿಂದ ತಗೋಬೇಕು. ಎ, ಓಕೆ. ಸೊ ನಾವು ಇಫ್ ಯು ಟೇಕ್ ಎ ಸಿ ಯು ಆರ್ ಗೋಯಿಂಗ್ ಟು ಗೆಟ್ ಎ 2 ಅನ್ನೌನ್ಸ್ ಹಿಯರ್. ಸಿ ಪಾಯಿಂಟಿಂದ ತೊಗೊಂಡ್ರೆ ಏನಾಗುತ್ತೆ, ನಿಮಗೆ 2 ಅನ್ನೌನ್ ಬರ್ತವೆ. ಆರ್ ಎ ಒಂದು ಅನ್ನೌನ್ ಬರ್ತದೆ, ಆರ್ ಬಿ ಒಂದು ಅನ್ನೌನ್ ಬರ್ತದೆ. ಹೌದಾ? ಅದಕ್ಕೆ ನಾನೇನು ಮಾಡ್ತೀನಿ, ಐ ಆಮ್ ಗೋಯಿಂಗ್ ಟು ಟೇಕ್ ಎ ಮೂಮೆಂಟ್ ಅಬೌಟ್ ಎ ಆ್ಯಂಡ್ ಇಕ್ವೇಟಿಂಗ್ ಇಟ್ ಟು 0 ಫಾರ್ ಇಕ್ವಿಲಿಬ್ರಿಯಂ ಸ್ಟೇಟ್. ಸೊ ನಾವು taking moment about A and equating it to 0 for equilibrium condition. Minus 250 into 3813 3.8 minus 500 RB plus 750 into 2156.92 equal to 0. So now we calculate RB. 1328 point. Okay. Noted. Or else we can directly calculate the bending moments as you know the end point load. Directly bending moment calculations ಮಾಡಬಹುದು. Okay. ಯಾಕೆಂದರೆ ನಿಮಗೆ ಎಂಡ್ ಪಾಯಿಂಟ್ ಲೋಡ್ ಅದ ಮಿಡ್ ಪಾಯಿಂಟ್ ಎಲ್ಲಿ ಲೋಡ್ ಇಲ್ಲ. ಸಪೋಸ್ ಮಿಡ್ ಪಾಯಿಂಟ್ ಎಲ್ಲರೂ ಲೋಡ್ ಬಂತಂದರೆ ನೀವು ರಿಯಾಕ್ಷನ್ಸ್ ಫೋರ್ಸ್ ಯೂಸ್ ಮಾಡಿ ಆ ಮೂಮೆಂಟ್ ಕ್ಯಾಲ್ಕುಲೇಷನ್ಸ್ ಮಾಡಬೇಕು. ಎವ್ರಿವನ್ ಗಾಟ್ ಆರ್ ಬಿ equal to 1328.45. Okay. Now RA equal to RA plus RB equal to 3813.9 plus 2183.6. Now let us calculate RA equal to 3813.9 plus 2183.6 minus RB. How much you got? 13. Okay. Now we calculate how much you are going to get. ಎಷ್ಟು ಬರುತ್ತೆ? Four six. Next step. Okay. Next. Now, bending moment at A. Okay. Bending moment at A. So bending moment at C is a 0. Let us go by one by one. Bending moment at C. Okay. So BM at C is 0. Now bending moment at A equal to, so F1 into 250. F1 into 250. So F1 is how much? 3813.9 into 250. Nine five 347. Okay. Now bending moment 9532. Let it be. So BM at B equal to F2 into 250. So this moment is going to cause a hogging. Another moment is also going to cause hogging. Okay. So we'll take it as a negative. Five. So now if you draw the bending moment diagram here, this point is A, this point is B, this point is C, and this point is D. At a D, at a C, you got a 0 value. Okay. At A, how much you got? 9, 5. At B, you got a 5, 3. This is what? 9, 5, 3, 4, 7, 7. 5, 3, 9, 2, 3, 2. ಹೇಳ ಬರೋಣ ಏನಾಯ್ತು ನಿಮ್ದು ಏನು ಬಂದದ ಅದನ್ನು ಬರೀರಿ Okay, you note down data and book equation. Okay, D naught equal to. So now for solid shaft, so D naught equal to D, capital K equal to 0. Now sigma D equal to sigma Y divided by FYS. Okay, it is a 380 divided by 3. So how much you are going to get? 63.33. 126.66. I think you got all values. You calculate how much you are going to get.